Hi everyone, welcome back. We are in our last week for for software analysis and design. And today we'll talk about focus flow, best practices, and good habits for modeling. So quite a couple of things to get through. First things first, checking in. How you doing today? Where are you? Are you being really present in your body? Are you distracted in your head, or are you like fully here and ready to go? I want to invite you to let everything just float away that is not part of this course right now. All the important thoughts, they're still going to be there when you come out of this lecture. It's almost like going into meditation now. We're going to meditate on the content of what we're going to talk about today. So take a deep breath. And then let go of everything that doesn't serve right now. Good. Be present behind your eyes. Feel the inside of your body. Maybe sit a little bit taller. Let's do this. So today we'll talk about focus flow, what I mean by that, and neuroplasticity for a little bit. Then best practices for software design and good habits. And then some more industry guidance, which is specifically from an Agile perspective. And then we'll get back to the learning objectives of this course and have a few exercises throughout this longer sequence today that's kind of in a workshop setting, because there will be several sequences of now I'm asking you to do something. So let's dive in. Focus flow. This whole checking in business at the beginning of the lecture. Maybe you're wondering why on earth I'm doing that. So the reason behind this is a lot of the time, and especially if we are in a completely virtual setting and everything is in this like magic little box, your computer or your phone or whatever it is, or your tablet, then there's lots of things going on at the same time. So as in this little drawing that I made, there could be some thoughts about scheduling meetings and, oh, I still need to write this report. And then, oh, I got to model that other thing. And then some emails that I need to reply to. Ooh, and I need to update my CV for reviewing and for sending an application. And oh, and I got to finish these other reviews. And it's kind of this to-do list that we keep running after. And it's always kind of a wash, rinse, and a repeat. So it's really hard to get some decent white space in our heads with requests that keep pouring in every day and with deadlines that we have throughout the week and every week again. And so there is a high potential that we just get to some cognitive overload, as symbolized by the little lightning bolts around the head of that stick figure. And then the consequence of that is that our performance goes down significantly, our productivity goes down significantly. So when our workload is at a decent level, we can be productive to a good output level. As our cognitive load becomes too high, that productivity takes a steep dive, which means that learning gets really hard and everything takes a lot more effort than it needs to. Now, the question is, how do we deal with that? There's a lot of requests that keep coming in. And one of the things that give us an indicator of how strong we are under the influence of all these things is the mindfulness awareness attention scale. So it's a little survey that you can take that will give you an idea of how present you are in your everyday activities or how distracted you are while you carry them out. So at this point, first exercise for the day, I want to invite you to fill out the survey on your everyday perceptions. It's completely anonymous. I will not know who you are, and there is no way for you to, for me to relate that data to the course if you are participating in this course at the university, and even less so if you just came across this video on the internet. So I just invite you to click that link and fill out that little survey. It's going to take you less than 5 minutes, and don't worry about picking an answer as it should be, because this is only for yourself. This is only for your assessment of, hey, how present am I being with my everyday activities? And then you can count your score of how often you rated yourself on a certain scale, or at what level. So hit pause now, head over there to the link, put it in the comments as well. You back? All right, cool. Then let's continue. So maybe that gives you a bit of an idea of how much you are currently under a significant cognitive load that kind of prevents you from being really present with things that are going on. The question is now, is there a way to change that? And how does my brain even deal with that? And there's this really interesting term of neuroplasticity. Neuroplasticity means the synaptic activation and how it makes your brain grow when it does get activated. So neuroplasticity means we're building new neuronal connections in between different parts of the brain. And that enhances your overall cognitive abilities and your productivity and your creativity and all those things. So when we have synaptic activation, it can either be weak, like you're on the left side, then it doesn't change any of your synapses. Or if it is a strong and frequent activation, then it can change your synaptic structure. And it strengthens the connections every time. And so the implication of that, seminar style training is not quite enough. So all of the learning that we do needs some ongoing reinforcement. And you know that from whatever you have ever taken a course on or a lecture in, if you only listen to the lecture, but you don't actually try the things out and repeat them and get feedback and then improve on what you did, then it doesn't stick that much. So we want to use technology to keep activating these synapses and to keep going through some repeat motion so that we can actually change our synaptic structure and learn and improve. A very interesting factor in here is a neurochemical called brain-derived neurotrophic growth factor. It's a neurochemical responsible for the growth and maintenance of your neural connections, of your synapses. So if neuroplasticity is the ability of the brain to rewire and rebuild itself, to form new neural networks and reinforce familiar neural connections, then BDNF, which is the shortcut for that brain-derived neurotrophic growth factor, helps your brain to adapt and learn, and it improves all forms of plasticity. So far, so good. It gets pretty theoretical here, but now we're going to bring it back to the ground level, because what significantly helps your BDNF levels is nutrition. For example, sugar reduces BDNF levels, while fasting, ketosis, and omega-3 fatty acids improve BDNF levels. And then for sleep, poor sleep reduces BDNF levels. So healthy sleep hygiene, like have an actually dark room and make sure you don't use screens for at least a couple of hours before you go to bed, and make sure that your sleeping room is on the cooler side, and keep your phone and your laptop and your wireless out of your bedroom, or at least on the far other side, and so on and so forth. Exercise, third component. So movement and exercise at any age will improve your BDNF levels. And then last one, chronic stress. So imbalances in cortisol and adrenaline lower BDNF levels, which means if we get back to that picture of the cognitive overload, that leads to elevated cortisol and adrenaline levels. And so that decreases your BDNF levels and therefore decreases neuroplasticity. So in a slightly simpler picture here, why do you care about your BDNF? It helps your brain adapt and learn. and it improves all forms of plasticity. And you can control your BDNF levels by exercise, by good sleep, by good nutrition, and by lowering your stress levels. So far, so good. And the thing is, when we hear things like that, like, oh yeah, that makes sense. And yeah, I've kind of heard this before. Of course, decent sleep, of course, good nutrition, of course, exercise, and of course, I should lower my stress. But like, I heard this before. Good. Are you making those choices every day? One of the things that helps us make these choices every day is, first of all, establish them. 21 days. You may have heard that rule of thumb before, and that's just the beginning. Like, that's where you see, oh, it's becoming a habit. That doesn't mean it's going to stick. How often have you done something for a while and then kind of given up on it again? So we know those 21 days, they're just the beginning. And one thing that often works well is to make the good choice the easier one. So whatever that means for you, whether that means to put your running shoes next to your bed, so when you wake up, you go right into them, or whether that means you make sure you go shopping for vegetables once a week so that you always have some fresh veggies and fruits in your fridge or in your apartment, so that you don't even want to buy some snack foods because you have your better choices right there. And the earlier you adapt in this, the better you will thrive. So a lot of you, when you watch this, you may be in your early 20s if you do this at university, and your metabolism is on fire. You can still eat whatever. It still influences your BDNF levels. And changing your nutritional habits becomes harder with every single year, because guess what? Your old neural pathways have become really ingrained. So the earlier you change, the better you will thrive. If you still haven't had enough, if you want to dive a little deeper, there's some really interesting work on brainwaves out there to help you kind of get into the zone, and that can also improve your neuroplasticity. So you see here different stages of those brain waves, and some of them are really helpful for learning and for retaining stuff, and others are helpful for deep relaxation. So you see here that a lot of the time we hang out in the beta waves, and if we hang out in the beta waves too much, that can lead to exhaustion, anxiety, and tension. When we get to alpha waves, we're a little more relaxed. We're still alert. So that is a state that helps really good for visualization and creativity and learning. So I like to listen to alpha wave music a lot while I am concentratedly working, because that way I'm not in this state, in this like very active state that is a little stressful. I'm a little more mellow, but super focused. When you get to theta waves, that is where you are in REM dream and in deep sleep. And delta is deep dreamless sleep. So you can use delta wave music if you have trouble falling asleep in the evening. And then gamma waves, those are for hyper brain activity, for big euphoria. So I hope you know what that feels like, and I hope you have a few activities that can help you get there. If not, that is a thing worth figuring out. And it can also be supported by music. There's plenty of free stuff on YouTube and probably also other music apps to listen to based on brainwaves, so that you can stimulate learning or relaxing. Why am I interested in all of this? I'm a software engineer, yes. And I've taken a deep dive into a lot of Eastern and Western ancient traditions that help us become better, more healthy, physically, emotionally, mentally. And I think that as engineers, we can learn a lot from those. And it all ties in with current neuroscience that supports this. So this is a project plan that I've developed and that I want to be following through. And a couple of you have joined the pilot study that is mentioned here during 2020. And then there's some data analysis I want to develop over time, and then some evaluation studies of interventions that I'm proposing. And if you want more of that, or if you want to continue after this course, please reach out to me, because there's a lot to be done in this field. And I think there's a lot to be learned for all of us. And with that, I would like to point you to a second exercise. So I have a 5-minute article for you to read. It's about what is your remedy to cognitive overload, which details a little bit more what I said at the beginning of this section of the lecture about here are a couple of things that cause cognitive overload, and then what does that mean? And then after you read the article, answer the linked survey about what are your healthy habits? Just curious. Same story. There is no way for me to find out who you are. It's completely anonymous. There's no tracking involved or anything. And I am super curious what you have to contribute. And with that, hit pause. Do the thing. I'll be waiting here for you. All right, we're back. Good. Let's carry on. So I want to wrap up this section by saying this is not about pampering. You know, sometimes we have that feeling of, ooh, self-care, like, does that mean that I have to bathe in milk every full moon night? And like, no, that's not what it's about. Like, it's really about becoming physically, mentally, and emotionally fit to be able to survive and to thrive in all the daily challenges that get thrown at us. And I think it deserves a lot more importance in our everyday lives. We keep casting it aside and saying it's a nice extra add-on. Oh, if I have the time, then I still do something to make sure my body is okay. Like, nope. Like, this is the foundation. If you take care of that foundation, then everything else will be a lot easier. And you know, it's a constant practice. I'm not telling you that I always succeed in that. There are days when I thoroughly fail on all accounts, spend too many hours in front of the laptop working myself to death, and at the end of the night I'm like, why did I do this to myself? The last 3 hours were so unproductive. So let's all work on our balance. I'm just one of them. Good. With that, we are jumping into the second part. It's about best practices and habits. So I want to walk you through a few of the habits that we already talked about earlier this semester, and I think I'm adding 1 or 2 new ones. So this is all from the book by Peter and Van der Hoek, the Software Design Decoded one, that is based on data that they have collected over 10 years on many software designers and the habits that make them good software designers. So they've talked to a bunch of people who are very well established in the industry and who are super experienced and who really are on their A game. And with that, here are some of the ones that have come up and that have been specifically relevant for us in this course. Experts divide and conquer. Experts know when and how to break down a complex problem into smaller problems that can be solved independently. In addressing the parts, however, they do not forget about the whole. They reflect on the relationships between parts. When what emerges in solving one part affects other parts, they make adjustments. Indeed, they sometimes repartition the whole problem and solution as a result. Now you see on the left a very simple design pattern of model view controller. What's important here is that I've seen most of you practice this successfully in your assignments, in your team assignments. You're like, oh yeah, divide and conquer. Sure, we got that down. Yeah. The divide, yes. and then look back at the middle of that little paragraph. However, they do not forget about the whole. They reflect on the relationships between parts. So in some of the assignments, it has been problematic that things are not consistent with each other, and that there was not enough communication coming around full circle to then talk about what does that mean for the whole and how do we make this one good overall deliverable. So keep that in mind. Yes, divide and conquer, and that means reflect on the relationship between the parts and bring it back together at the end. Next one, peer review. Experts socially embed and reinforce good practice. So on the left, you see this sketch of a diagram and somebody wrote some feedback on it. Had a read and write here, and then, oh, triggers should use the observer pattern. And cool design, some flexibility needed though. And then you should add a lock and an unlock, and it's still got to be tested with the JMeter. So experts know that the interplay between designers plays a crucial part both in nurturing creativity and in promoting quality and rigor. They consciously embed and reinforce good practice in their teams. They use knowledge of the group, of both individual and combined strengths and limitations, to structure activities, provide systematic checks, and share knowledge. This collective safety net liberates individuals to extend themselves. Experts especially take care over the induction of new members into local culture and practice while eliciting fresh perspectives from them. Sweet. So you have all practiced peer review this semester, and you found that, you know what, it's not that easy to write good feedback. Yes, it's not. I know it was time limited and all these things. It's not that easy to give good feedback. So using your checklists that you use for your own assignments and then apply those checklists when you perform a review is a good way to start it. And then really think through the other person's design. And this one is a good one to keep cultivating. So also, as you prepare for the final exam on this course, make sure that you exchange solutions with each other and get some feedback on them from each other. You can also contact your TAs, of course, and it's important for you to perform some peer reviewing as well. Not just that you get feedback on your solutions, but also that you look at somebody else's designs and think about how could that possibly be improved. Next one. Experts draw the problem as much as they draw the solution. Experts know that their understanding of the design problem and their understanding of its solution inevitably deepen and co-evolve as they design. Experts therefore draw the problem as much as they draw the solution. By moving back and forth, they not only ensure that both stay in sync, but also explicitly use advances in the understanding of one to drive advances in the understanding of the other. Good. So this one we've talked about a bunch of times, and in this traffic example, you see some very early idea of elements that are interacting with each other, and then a scenario of what that looks like in real life. And that is something that is at the core of this course because it's called analysis and design. So we're going back and forth in between the two. Analyze the scenario on the right and then design what is happening on the left. So keep working on that. Experts focus on the essence. Every design problem has an essence, a core set of considerations that must be understood and nailed in the design solution for it to solve the problem successfully. This essence can be disruptive. Changes in the core drastically alter the peripheral decisions that need to be made. Experts focus their efforts on the essence first and delay expending effort designing on the periphery. That design principle we've also looked at a couple of times across the course. And it addresses focus on the core problem. So whenever I give you a new system to work with, for whichever diagrams, for whichever type of modeling, to analyze whatever, I want you to think about what is the core problem? What is the most difficult thing? What is the most crucial problem to solve for the system at hand? Good. And then experts move among levels of abstraction. Experts design their solutions as multiple levels of abstraction concurrently. They know that focusing only on high-level models is likely to omit important detail, and that working only on low-level code is likely to lead to inelegant solutions. In exploring a design solution, they deliberately move up and down among levels of abstraction and use resonances among them to spark insights and identify problems. So on the left, you see the system, architecture, TCP/IP messages, and packages. So all of those are in different levels of abstraction. The system level, that's the one where you need the telescope because you're on a very high level of abstraction. Architecture, you got the binoculars. TCP/IP messages, we're fairly close. You already have a magnifying glass. And then for the packet level, you have a microscope. So levels of abstraction that we've gone through in this course is from use cases to classes to components. So from very abstract on the black box level to the low-level design, close to the implementation, and also from scenarios to sequence, state, and activity diagrams. So the top ones are structural and the bottom ones are behavioral. Several levels of abstraction, and keep working through all of those and keep them consistent. Experts simulate continually. So experts imagine how a design will work, simulating aspects of the envisioned software and how the different parts of the design support a variety of scenarios. When working with others, experts regularly walk through a design by verbalizing its operation step by step. When alone, they simulate mentally, exercising the design repeatedly over time. So in the picture on the left, there is a software developer looking over their notes and trying to simulate in their head what's going on as the hamster is in the wheel or something like that. And what I want you to take away from that is to walk through your solution design. So when you've come up with your first design, go back to the use case, put that into play and think about, okay, what does my design look like as I walk through this use case step by step? What are the individual components and classes and steps that become active as I go through this? That's going to be a good quality assurance for your solution design. Second one of walking through your solution design, experts draw examples alongside the diagrams. So on their own, design diagrams remain passive abstractions. This is why experts draw examples alongside the diagrams when they simulate a design. Externalizing their thoughts, juxtaposing the simulation with their design, and envisioning the execution in context forces them to interpret what they drew and to test their design more thoroughly in the process. So in the example on the left, traffic light controller, if car approaches intersection, if intersection light is red, car speed is 0, else if intersection light is yellow, car speed plus 10. That's something that you see very frequently at traffic intersections. It turns yellow and most people speed up to try and make it across instead of slowing down. So here you see in the scenario, person with the finger on that little car is playing through the example of what happens if and trying out the different cases. With those best practices from the large scale study of many, many software architects across a lot of different industries, I want to tune into one more specific example from an industry perspective, which is Agile modeling. So we've looked at the work of Scott Ambler a couple of times from Ambisoft and his view on best practices in Agile modeling. And here you see an overview about that includes test-driven development, model storming, architecture envisioning, just barely good enough, document continuously, all those things. Document continuously. Remember, there is good documentation in Agile. It's just to the necessary, limited. So with these core practices that are referenced here and discussed in more detail, so stakeholder participation, that they get input in a timely manner, architecture and visioning, you will do some high-level initial architecture modeling to identify a viable technical strategy, then document continuously throughout the life cycle, document late so there is not as much speculation in there. Make sure you have executable specifications. That means you have some customer tests executable along with it, and iteration modeling. So you do a bit of modeling with part of your iteration planning, and just barely good enough artifacts, just enough for the situation at hand, no more. Look ahead modeling. So sometimes as items get close to the priority stack, to the top of the priority stack, then try to get them done before it's super crucial so that the overall risk gets reduced. Model storm means you have a just-in-time basis to explore the details of an idea before you implement it in the design. Multiple models. So you will always need a range of models to find the right one for a given situation, and then prioritize your requirements as defined by the stakeholders, so you get your greatest return on investment for the product. And then requirements envisioning means think about the scope and then have an initial prioritized stack of requirements. Single source information, super important that you have information in only one place, because otherwise it's really painful to update it in 3 different places if you have it strewn across. And what usually happens is then you forget one place to update it. And then finally, the test-driven design. So a single test and then just enough code to fulfill that. And that helps detailing your requirement specification. So far, for his good agile modeling practices. But now what Scott does, I find really interesting. He started questioning those best practices for software development, because actually they're contextual. They're never best. So he says a very popular term within the IT community is best practice, and it's a wonderful marketing term. How could someone possibly argue about adopting a best practice? But the question is, does that concept really make sense? Not so sure. There are many examples where a practice that is considered best in one context is questionable within another, and we'll get to those. And as professionals, it seems to me that we should strive to understand the context which we find ourselves in, and then apply the practice which is best within that given context. So in other words, we should really be focused on contextual practices and not best practices. The trouble with that is best practices sells better in marketing. And unfortunately, sometimes in our industry, it's more about the sales than about the truth. And so take that with you as a term, contextual practice, not best practice. And here are a couple of examples for that. So when you observe what's going on within the Agile community, it becomes clear that many best practices really aren't so much. For example, reviews. When you consider model reviews, an activity which I have said earlier in this course is important, and yes, I would say it's still important and you need to practice that. That needs to be in your toolbox. You know, they are right. On a traditional software project, reviewing source code models and documents is a best practice because it's a technique which enables you to validate your work early in the life cycle when problems are less expensive to address. But model reviews don't always make sense on Agile projects. So when you've adopted Agile modeling practices, for example, the active stakeholder participation, model with others, apply modeling standards, and display the models publicly, then you discover that additional reviews may not add that much value. Why is that? Because model reviews compensate for poor communication in the first place, when not everybody was collaborating. You should have been collaborating on this. And for individuals who are working on their own and don't get enough input from others. So it really depends on your development situation. And some traditional teams do suffer from these problems. They often have specialists, for example, business analysts, database designers, testers, and programmers who create those artifacts and then hand them off to the next specialist downstream from them and allow specialists to work on their artifacts in a relative seclusion from the rest of the team. And this approach is risky. And therefore, model and documentation reviews compensate for those risks. And if you choose to work that way, then model reviews are a good idea. And they are a best practice for these teams. Agile teams, on the other hand, they don't make those similar mistakes. They make others. Agilists are often generalizing specialists with a wide range of skills. They don't need to hand off work to others. Instead, they collaborate with them to get the job done. Agile teams communicate and collaborate openly. They share artifacts and work on them together. They typically don't assign ownership to individuals and thereby don't risk the owner going off in a different direction from the rest of the team. And because Agile teams don't suffer from problems with model reviews, they compensate for it. They find that model reviews are not a best practice, and they might even be detracting from their success. More examples. Modeling everything up front so as to get it right. Agilists are discovering that you're far more effective to model storm and just in time because your team's understanding of the domain changes over time. You can ask more intelligent questions based on your greater knowledge, and your stakeholders can provide more intelligent answers because of their better understanding. Another one is building teams of specialists. Agilists are finding that specialists do far too much work. So a use case modeling specialist will create really great use cases, whether you need them or not, and have problems interacting with other specialists. The Java expert doesn't appreciate or understand the implications of what the database expert is trying to achieve, and vice versa. So it might be better to build teams from generalizing specialists, people with one or more specialties who have a general understanding of the software process and of the domain. And these people have the ability to apply the right artifact for their current situation, instead of just the artifact that they already know, for example, use cases, and thereby they're more effective. Last, detailed project plans. Many traditional teams will develop detailed project plans early in the project and invest considerable amounts of time updating the plan to reflect the actual results. Agilists take a rolling wave approach to planning. They create a high-level plan showing the major dependencies and development cycles and iterations, and then at the beginning of a cycle, as a team, we identify the tasks we need to perform to accomplish our goals. Just-in-time planning by the people who will do the work is far more effective for working. With that, I hope you have a good sense of maybe it's better to talk about contextual practices as opposed to best practices. Now, how do we get towards those contextual practices? Ideally, we do that depending on the context, because sometimes a practice is best and sometimes it's not. And there is a software development context framework that helps to provide insight into the context which IT teams find themselves in. And it describes several factors which provide this context. The factors are team size, from teams of a few people to thousands, geographic distribution, from people being co-located to being distributed around the world, organizational distribution, from everyone working in the same organizational unit to people working for different organizations, so such as outsourced service providers, for example. Regulatory compliance, so from being non-regulated, I'm just going to throw the next app out there for a game, to very strict regulation. I have a safety critical system, I have a nuclear power plant, or I have FDA regulations, something about Food and Drug Administration. Those have to be treated very differently. Domain complexity. So from very simple problems, Candy Crush, anyone, to very complex ones, flying a rocket into space. Technical complexity. So from greenfield single platform systems to multi-platform systems using legacy systems and data. From let me throw out the next dating app to let me build a banking system for this bank that's been running on an old Fortran system for 20 years. Organizational complexity, from organizations which are very flexible and collaborative to organizations which are very rigid and strict. So from the new startup to the government. Paradigm, are you following a process which is agile, lean, traditional, classical, ad hoc, or a hybrid combination of those? That will have a strong influence on your practices and what contextually would be best practices. So the point is that different teams find themselves in different situations, different contexts, if you will. And therefore, they will tailor their approach to reflect that situation. And they will adopt practices which meet their needs and tailor those practices accordingly, particularly when provided with the process, goals-based strategy implemented via frameworks such as disciplined agile delivery. So that's a little pointer if you want to dive deeper into the agile domain. But as a general framework, this outline will help you get a sense of what's your context like. Like going through these 8 bullet points will give you a good sense of what type of software development might be appropriate here in your given situation. Third part, learning objectives. So this is what you came for, if you will. We have learning objectives in the areas of knowledge and understanding, in the area of skills and abilities, and in the area of judgment and approach for this course. And specifically, software analysis and design wants to teach you for knowledge and understanding to explain guidelines and heuristics for performing a domain analysis. You shall be able to explain how to represent a software system using UML models. In the area of skills and abilities, you shall be able to analyze and design software systems using object-oriented techniques. You shall be able to create a UML model that is an abstract representation of the source code. And you shall be able to use tools for domain and requirements analysis, modeling, program visualization, and object-oriented program design. In the area of judgment and approach, you shall be able to analyze how software design principles and patterns impact software quality. And you shall be able to reflect on and resolve inconsistencies between various models used as part of a single system's design. Now, the question that we all need to ask ourselves is, did you get there this semester? And how would you know that? So I've broken these down into how to show each hint. That'll give you a good idea of what could be coming your way for the exam in this course. And if you're not taking this in the regular university setting, here are some example questions of how you can test whether you really got what we're talking about in this course. So for explaining guidelines and heuristics for performing a domain analysis, one question you may ask yourself is, how would you approach a domain analysis for a COVID-19 tracker app for connections that warns about potential infections from people that the user has met? So using that example, you could explain how you would go about this. Second one, explain how to represent a software system using UML models. A question, for example, that could test your knowledge on if you can explain how to represent that is, which 3 diagram types would you use primarily to represent such a system, and why would you choose those? So we're still talking about that COVID tracker app. Which diagram types would you say are most useful here, and why would you argue that that is so? And you can find arguments for a lot of diagram types here. So it's not, do I find the right 3 diagram types? It's about your argumentation. Why would you consider that choosing those 3 is the most important in this case? Number 3, analyze and design software systems using object-oriented techniques. So one prompt to check whether you can do that is perform a domain analysis for the following system description for the COVID-19 tracker app. And then you would get a more detailed description of the context and use cases. Or you can write that description of context and use cases yourself, just based upon the prompt in number 1. Then you can see whether, first of all, you know how to write the use cases, and then second, do you know how then to deal with the use case descriptions to turn that into a domain analysis and to perform a domain analysis on those use cases. Number 4, create a UML model that is an abstract representation of the source code. One way to check this is if I give you sample code, a page of sample code that you can turn into a class diagram and an activity diagram, so that you can show both the structural representation and the behavioral representation. And of course, they would have to be consistent with each other. The class diagram consistent with the activity diagram. Number 5, use tools for domain and requirements analysis, modeling, program visualization, and object-oriented program design. One prompt that could test that is draw a UML state diagram for the COVID-19 app using your tool of choice. And so there's plenty of UML tools out there. You're free to use whichever one you want. Show that you can. Analyze, number 6, analyze how software design principles and patterns impact software quality. One way we could check that is to say, which design principle would you say would help to improve this design? And then I'd give you an example diagram that needs improvement. So I might give you a class diagram where there's just way too many connections in between all the things. Then one of the ways to answer that is to say, oh, they probably didn't do a very good job at modularization and at information hiding. And then you can talk about these principles and how that would help improve the design. And make suggestions for how to do that for the specific example diagram. And then number 7, finally, reflect on and resolve inconsistencies between various models used as part of a single systems design. So a prompt here could be resolve the inconsistencies between those 2 diagrams. And then you would get 2 diagrams, for example, a sequence diagram and a state diagram, and they are just inconsistent with each other. Something in one diagram does not fit with how this looks like in the other diagram, or an activity diagram and a class diagram, or a class diagram and a sequence diagram. So all of these should be consistent with each other, and you can check whether they are. So there is your guide to how can you make sure you've achieved the learning objectives for this course, and how can you show that you have achieved them. And with that, we get to the final exercise part for today, the modeling practice. So a couple of example questions and prompts of what that could look like. And we're going to do that with the example of the camping reservation system called Check Me In. Camping is a very popular way of celebrating the holidays and is done by people all around the globe. For a lot of people, one of the advantages of camping is that they don't have to reserve a spot on a camping place. Normally, they would just check by phone if there is a spot available once they're approaching a camping place. A little problematic for camping places is that this can lead to large queues in front of the reception building. And this is the place where the clients have to check in and pay. To overcome these large queues, a camping reservation system is going to be developed, and we call this the Check Me In system. You see a little picture of what that Check Me In system could look like in the bottom right corner of the slide. A little more description. Check Me In is capable of a number of things, such as checking free spots, reserving the spot, and handling of the payments. On the campsite, the system controls a gate that is secured with a PIN code, and the schema you saw on the previous slide. When a client arrives at a campsite, they go to a terminal, which is just a touch screen, could be an input device for the system. It doesn't contain software. On the screen, the client selects the preferred language and starts the check-in procedure by touching the Check Me In button. The system shows a map of free camp spots, depending on the amount of nights the person wants to stay. If there are no available spots, the system shows a message and ends the procedure. When a free spot is chosen, Check Me In asks for personal information, such as the client's home address, email, tent size, and the number of persons that want to stay. The next step is payment. The payment screen asks for credit card information and when the client approves the payment is done. After the payment is done, the client receives a code for the gate. This is printed on paper through the terminal and is sent by email to the client. Entering and leaving the campsite is done by entering the PIN code at the gate. If payment was in order, the client is able to enter or leave the campsite. If not, the gate stays closed. In case of problems, the client can always go to the reception of the campsite. The receptionist can manage all clients' reservations. If the gate itself is an external system to the Check Me In system. Checking out is done automatically after exceeding the checkout time of noon on the last camping day. After that time, the PIN code is invalid and the spot is set to free. An early checkout can be done by walking to one of the terminals and touching the Check Me Out button. After entering the PIN code and confirming the checkout, the system sets the camping spot to free. Checking out with the terminal can also be used when the client is too late, after 12. And after paying the extra costs, the client is checked out and can leave the camping place within half an hour. After that time, the PIN code is invalid again and the spot is set to free. Extra system functionalities are that the system's API enables clients to use a mobile app to use the following functions online, which is via the internet. Check-in and check-out, including payment, showing available spots at particular dates. The mobile app is seen as an external system. Now, for the development of the Check Me In systems, there is also some requirements that are written down. Application system requirements. In the future, the system should also be able to support other kinds of accommodation than described in the case text. In this way, the app could be used for other types of camping places, for example, with prepared tents or bungalows. Also, the support of more types of accommodation makes the system useful for other companies. The application uses an attractive graphical user interface. In general, the software should be maintainable, extensible, and changeable, or modifiable. Hardware requirements are that the input and output is done with a touchscreen terminal, and the system is connected to the internet. Technical software requirements are that the program language for implementing the system is Java, object-oriented, and the system uses a couple of predefined software classes. Gate controller, which is responsible for sending signals that open or close the gate. Payment controller, that is handling communication with the various banking systems. Canvas, which is the GUI module that is responsible for showing the graphical components of the application, such as touch buttons and text messages. And the canvas consists of several implementations of graphical component, which is a reusable class that is responsible for handling events of graphical components. Touch button and message area are specializations of this class. There should be a class that has a role as central control unit. The remainder of the design is left to the developer, to you, and must be obtained by text analysis. For example, reservation, client, and so on from the two previous slides. And here are the things that you're being asked to do. First, use case-based requirements. Make a use case diagram and include at least 2 sensible use cases in addition to the use case check-in. The use case pay reservation is initiated from check-in. Next to the main use case, the answer should at least include or extend use case. B, give a use case description, including one alternative flow of check-in following the standard notation. And just as a little reminder, you see that on the bottom of the right. So hit pause, get started on that. Next one, problem domain modeling. Build a domain model of the problem domain presented in the description on those 2 pages through the use of a UML class diagram. You should consider using the richness of UML, such as association names, composition, aggregation, inheritance relationships, and multiplicities where appropriate. Again, hit pause, go back to those slides, get started on the main modeling. 3, design modeling. Design the initial software structure for the Check Me In system with the use of 1, a UML class diagram, and 2, a sequence diagram. The design level class diagram focuses on implementation aspects. The design should consider the requirements on the requirements page. For full score, all classes, attributes, methods, and associations, association names, cardinalities, and inheritance relationships should be defined. Also, coupling and cohesion are considered. Procedure that I'd recommend is create 1 design class model by first constructing 2 sequence diagrams, or do the other way around. Do the sequence diagrams and then the class model for 1 check-in, a client, and open gate with the pin code. The answer should consist of the final sequence and class diagram, and the diagrams should be consistent with each other. Again, hit pause, get to work on that. Number 4, design principles and patterns. Part A, organize your design, the class diagram from P3, in a layered architecture. Draw the classes without the details of attributes and operations. Use proper names for the layers. After introducing that layering, it's possible that design principles are violated. Mention which of those principles are violated and how that could be improved in the next generation of the design. Explain your answer. Don't have to alter the design. B, explain how the decorator pattern can support the application performance in the case of showing the campsite with its free and occupied spots. So if you don't remember what the decorator pattern is, look it up. You have all the sites for that. Hit pause, try that. And then P5, behavior modeling. The gate can be in different states: closed, opening, open, closing, and stopped. When the correct pin code is entered, the gate opens. So it goes to opening. The gate is open when it reaches a 90-degree angle. After 20 seconds, or when a car has passed, which is seen by a sensor, the gate goes to closing and eventually closed when it reaches a 0-degree angle. While opening and closing, red lights on the gate arm blink. The gate can enter the stopped state from closing when the sensor in the arm notices an object below the arm. And after 3 seconds, the gate enters the closing state to try again. The class gate controller always receives a state update. And now to model the behavior, first consider the gate as an object, and then 2, describe the behavior for the gate by using a UML state machine diagram. The state diagram should consist of proper internal do activities, transition triggers, and transition effects. It should involve method calls to the relevant objects of the class design of P3. It should be consistent with the answer on P3. With that, you have quite a bit to do. So that rounds off our workshop today. Get you going on those questions. Let's do this. So the solutions are not in the slide set because otherwise it would be way too easy to just go let me talk ahead and not hit pause and not actually do this. Remember, when we talked about the brain plasticity at the beginning, like this is how you really learn, by really doing it yourself and by practicing it yourself. So get to work and try to solve these. We'll talk about solutions next time. And your time to practice now. Check whether you've got this down. I know you do. You can do this. And just a little reminder, your education here, especially at university, even more so than at school before, it serves to teach you how to solve problems and how to become a leader. So all of that means you become active. You do the thing. Yes? Yes. Good. Got it. And thank you for watching. I will see you soon. Good luck with everything.